Lesson 12.2, Task 1. Investigate sums and differences of rational expressions. The addition and subtraction of rational expressions is very similar to adding and subtracting numerical fractions. Compare finding the sum of x plus 4 over x minus 4 plus 2x minus 16 over x minus 4 to find the sum finding the sum of 3/8 plus 1/8. All right, so if you remember, adding fractions, you add the numerator and keep the denominator. All right, so for 3/8 plus 1/8, you would add those and you would get 4/8. And then you would have to simplify if they have anything in common. So since 8 is 2 times 4, you could cancel the 4's out. And if there's no number left on top, that's assumed to be a 1. So don't write that as 2 because 2 is not the same as 1/2, but this is the same as 1/2. And 4/8, that should make sense that that's equivalent to 1/2. So what did we do? We added the numerators and we kept the denominator. Well, the same thing's going to happen with rational expressions. So we have x plus 4 over x minus 4, and then we have plus 2x minus 16. And we have x minus 4. Since they already have common denominators, we can keep the denominator and simply add the numerators. So you're going to add like terms. So since we have an x and a 2x, and we have x plus 2x, that means it would be 3x. And then we have 4 plus negative 16. 4 plus negative 16 is negative 12. All right, in the same sense that we simplified this to 1/2, we have to try to simplify this expression as well. All right, the denominator is already in simplified form, but the numerator has a common factor of 3. So if I factor 3 out of each term, 3 times x is 3x, and 3 times negative 4 is negative 12. All right, so I'm just using distributive property in reverse in order to factor this expression. All right, now when I do that, now I have a common factor, just like I did here with the 4's, and I can reduce that, and my answer is 3. Now I still have to look for excluded values like we did in the last section, and we know that x, the denominator, cannot be 0, so that means x cannot be whatever would make this 0. 4 minus 4 equals 0, so x cannot be 4. All right, let's see what the questions ask us. All right, so it says, for numerical fractions having like denominators means the fractions have the same number in their denominators. What does this mean for rational expressions? The rational expressions have the same expression as their denominator. That should be true. The rational expressions have the same expression as their numerator. The rational expressions have different expressions as their denominators. The rational expressions have different expressions as their numerators. So the rational expressions have the same expression here. It is just like having the same denominator here. So these both had a denominator of 8. These both had a denominator of x minus 4. Now that doesn't always happen. These are the easiest form, but that's what we are starting with here. All right. Since both addition problems involve like denominators, what will be the first step in finding each sum? Well, remember we just added the numerators. So it says add the denominators and place the sum under. That's not it. Add the numerators and place over like denominators. So that would be the correct answer. So you add the numerators and keep the denominators. Now they go through the process and show the same thing that I did. So 3 plus 1 is 4 over 8. And then they added here and got 3x minus 12 like I did. And let's see what the next question says. The first two steps for finding the sums are shown. The numerical expression 4 over 8 can be simplified further. Can the rational expression also be simplified? Explain. Alright, so yes, we simplified both of these, had a common term of 4. 4 goes into 4 one time. 4 goes into 8 2 times, so we reduced those by 4 and got 1/2. In a similar sense, we used factoring to factor out of 3 here, or divide a 3 out, which is the same as dividing out of 4 here, and we reduced that. So let's see what our choices are. No, the expressions are not the same. No, the numerator. Yes, break the fraction in 2. Yes, rewrite as this, then cancel the expression x minus 4. Okay, so you're going to rewrite it in factored form. You cannot break the fractions apart. You cannot separate these because they're a binomial. So that is not an option with rational expressions. These are actually joined, like these are joined together. You can factor them and rewrite it, but you cannot pull them apart like this. Creates a completely different problem. Alright, it says simplifying 3x minus 12 over x minus 4 requires factoring. How is factoring used to simplify 4 over 8? Alright, again, 4 over 8. 4 is 1 times 4. 8 is 2 times 4. And then you just use numbers instead of polynomial expressions. And it's still basically the same thing, just with numbers. And then you cancel out the 4's as you can see and simplify to get 1/2. Alright, that is all for task 1. If you have any questions, let me know. Lesson 12.2, task 2. Investigate sum and differences of rational expressions. Compare finding the difference of x plus 2 over x minus 3 minus 3x plus 16 over x squared minus x minus 6 to finding the difference of 11 over 12 minus 3 over 8. The first step in both subtraction problems is to find a common denominator. Alright, so remember when we added fractions in elementary school, you had to have a common denominator. So let's review real quickly. Alright, this is something you have to be able to do. So if you have 11 over 12 and you have minus 3 over 8, first you have to know, what do 12 and 8 both go into evenly? Alright, 8 does not go into 12, so I have to change both numbers, but I don't want to simply multiply by 12 and by 8 because then that's going to make a much larger number than I need. So think of multiples. What's the next multiple of 12? Well, that would be 24. Does 8 go into 24? Yes. So what I'm going to do is multiply this one by 2. And whatever I do on the bottom, I have to do the same thing to the top. Because if I change the top and the bottom both by 2, I'm making this number 2 times bigger. I'm just manipulating this fraction. I'm not changing the fraction. And that's the key. We can't change it. We just can manipulate it, rewrite it. Alright, 8, if I multiply 8 by 3, that gives me 24. And again, I have to do the same thing to the numerator as I do the denominator. So I'm not changing the problem. Alright, so this gives me 22 over 24 minus 9 over 24. Now, once I have a common denominator, I keep that denominator and I simplify just the numerator. So 22 minus 9 is 13, I believe. And this would be my fraction simplified. Now, the rational expression is a little bit more difficult, so I'm going to do it on this side. I'm going to have x plus 2, and that's over x minus 3. I'm going to have minus, and then 3x plus 16, and then x squared minus x minus 6. Alright, so we've already learned with rational expressions that we can factor, and if we factor, then sometimes that will help. So right now, I know that this first term, I can't do anything else with it right now. So what I'm going to do is look at factoring the denominator because we're trying to get a common denominator. So if I want to factor this, how would I rewrite it? I'm going to have x times x. what multiplies to give me 6 and adds to give me 1. So that's going to be 2 and 3. I need a negative 6 and a negative 1. My bigger number has to be negative. My 2 has to be positive. Alright, so I'm just going to leave 3x plus 16 for now. And actually what I'm going to do is I'm going to change this to a plus and put all of this with a negative. So I can distribute that negative here to make sure I don't lose it, because when I subtract with a binomial, just like long division that we did, you have to subtract all the way across. Alright, now if I look, I have a common factor here, but this one is not on this side. So just like where we had to multiply here to get a common denominator, we're going to multiply here by x plus 2. And that means we have to multiply the top as well by x plus 2. If we multiply by the same thing on top and bottom, we're just essentially multiplying by 1, and so it doesn't change anything. Alright, so now I have two binomials on top. If I want to put those together, I can. X squared plus 2x is 4x, and then 2 times 2 is 4. And I'm going to leave my denominator in factored form. Alright, and then I'm going to have plus, but I'm going to have plus and I've got to distribute that negative. So I'm going to have negative 3x and negative 16. And that way it's all one fraction. And if I want to simplify what's on top, I can write this as x squared. I've got 4x minus 3x. 4 minus 3 is just plus x, and I've got 4 and a negative 16, which is negative 12. And that's over x plus 2 and x minus 3. And then I may be able to factor this. I believe I can. So I'm going to have a 3 and a 4, multiply and give me 12, and give me 1 in the middle. I need a plus 4 and a minus 3. I'm going to have x plus 2 and x minus 3. And look at there. Now I can simplify further. So don't have much room to write that, but it's going to be x plus 4 over x plus 2 would be the simplified expression. Alright, let's see what kind of questions we have with task 2. Alright, how is finding a common denominator for numerical fractions and rational fractions both similar? Alright. So you use the factors to find common denominators, preferably the least common denominator. That would be true, because like remember here I wanted to do the least common denominator. It is difficult because rational expressions involve Alright, factoring rational expressions can be more complicated. As you can see, there's more steps, and you have to be able to multiply and factor and do several other things. So, rational expressions can be a little bit more difficult. Alright, the steps for finding the differences are shown. How is subtracting in the numerators of the rational expressions different from that of a rational or that of a numerical fraction? You can subtract, distributive property must be used. Alright, so this is the case. So remember here when I have a negative, I had to use distributive property there. That's because you don't want to lose that negative sign as you go across. Alright, the resulting numerical fraction cannot be simplified. Can the resulting rational expression be simplified? If so, explain. And we know it can because we already simplified it, and it's simplified down to x plus 4 over x plus 2. So, there you go. That's task 2. If you have any questions, please let me know.